Hello DSci 2000. In this video, we're going to continue our unit on data manipulation in R, and we are going to cover SQL joins in base R. Here's the usual objective slide. Please pause and read before proceeding. So we're going to ignore this slide for the most part. Here's what I want you to do. In your data files folder, please be sure that both cities.csv and simulatedmnsalaries.csv are both in your data files folder. The next thing we're going to do is we're going to go to our Git repository as usual, and I'm going to open up the rproj file. If you don't have it open already, please open the R markdown file from the last video. Here's how you do that. Go to the bottom right, click on Unit 5, and go to the intro to R.rmd file. This will open it on the top left. And now let's scroll all the way down, add in a blank line, and then a pound sign for a new section, and we're going to call this SQL joins in R. Throw a blank line there. Before you do anything, make sure your cursor is after the SQL joins in R section. Scroll up, click the arrow right next to run, and click run all chunks above. Now that we have run our old code, the next thing we're going to do is recall that in prior lectures, we have already loaded the simulated MN salaries file. We next need to load the cities file. So right here, I'm going to type that we are loading the cities.csv file. The next thing I'm going to do is I'm going to scroll all the way up back to when we loaded the simulated MN salaries file. I'm going to copy those lines and scroll all the way back down. And making sure I have a blank line in between my text and my code, I'm going to paste here. And I'm going to replace this with cities. And let's call this data frame cities as well. Go to the end of the line, press Ctrl Enter. Scroll to the top right. You should have two data frames in here before we proceed. The DF data frame, which was the simulated MN salaries data frame, as well as a new data frame called cities, which is the cities.csv data frame. Just a quick reminder of what's in these data. Let's click on DF. This contains a bunch of IDs, years, salaries, sex, race, and salary Canadian values, given what we had done in prior lectures. Going back to the right, let's look at what's in cities. Cities has ID values as well as corresponding city values. Our goal in this lecture is to learn how to append these city values to this data frame. We have IDs in here and we have IDs in here. Several of the IDs in this DF data frame can be associated with a cities value in the cities data frame. And our main goal in this lecture is to learn how to attach these cities to this data frame DF. I'm going to close these out and I'm going to add a new line here. Going back to the slides, this slide is just explaining that our goal is going to be to append these city values to our data frame DF. How do we do this? Here's the first thing I want you to observe. I'll let you run this code on your own. If you look at the number of unique IDs in DF, you get around 90,000. If you look at the number of unique IDs in cities, you get 25,000. One of the things you should always do before you join datasets together is you should get an idea of how many unique values there are in the fields you will be using to link your tables together. I am observing here that there are 90,000 or so IDs in DF and 25,000 or so IDs in cities. So I do not expect that we will be able to link absolutely every ID in DF to a corresponding city because there are so many more IDs in DF than there are in cities. So when you join these two data sets together, keep in mind the possibility that you may have blank values or values may be dropped. And you'll see what I mean by this in a second. Another thing that you should know is that ID is the only common column between DF and cities. It's not necessarily that they both have the same column name. It's that there's this one attribute called ID that is the only common attribute that you can use between an observation in DF and cities. So thus, we have to use the ID columns of both DF and cities to merge those tables together. There are four possible ways to merge these tables. What way you choose will depend on what you want the final product to be. The first type of way you can merge these two tables is an inner join. An inner join would involve merging the two data frames together, but only showing IDs that are in both data frames. An inner join I like to think of as only showing values of the ID in this case that exist in both data frames. Inner joins are always used when you want to only show the values that both tables have in common. This is probably one of the most common types of joins that I use on a daily basis. The second type of join is this. Let's say that I have my DF data frame containing my salaries, and I want to take that data frame, and regardless of whether there is a match in the city's data frame, I still want to append the city. Consequentially, what this will do is as follows. It will take the DF data frame consisting of the salaries and stick a city on the right of the DF data frame wherever a match exists. If a match does not exist, the city will just be NA. This is called a left join between DF and cities. The reason why it is called a left join is because between DF and cities, if I imagine those as being DF on the left and cities on the right, I'm going to use the DF IDs as my main source of data, and I'm going to append cities to these IDs regardless of whether there is a match. My main source of IDs is going to be what is on the left, i.e. the data frame DF. For this reason, using DF as the main source of IDs and then just appending cities to the DF data frame is just known as a left join between DF and cities. Because DF, if you imagine it being on the left between DF and cities, is the main source of IDs you are using to perform the merge. Inner joins and left joins, in my daily experience as a data professional, are the most common types of joins that I have to perform. The third type of join is as follows. It is known as a right join between DF and cities. Similar to the left join, we are using one of the two data frames as a primary source of IDs for doing the merge. A right join between DF and cities would be as follows. I want to use the IDs in cities, and then, regardless of whether there's a match, stick the DF columns to the right of what is in the cities column. This is known as a right join between DF and cities, because if I imagine DF and cities being on the left and right respectively, I'm using the right table, cities, as the main source of IDs for performing the merge. So we've discussed inner joins, left joins, and right joins. The next type of join we need to discuss is the full join. The full join is as follows. Take DF and take cities and match the IDs between both of them, regardless of whether there is a match or not. This could potentially result in blank columns in quite a few of your rows if there are no matches between the two tables. Full joins are generally used when you just want all of the IDs that exist and you don't care whether there is incomplete information. As some practical advice, I generally use inner joins when I only care about IDs that are in both data frames, or if I can trust that if I were to join these two tables based on an inner join, that no records would be dropped. Left joins are very common when I have one particular table I want to focus on and I just want to append data to it. Those two situations are the most common situations that I have run into as a data professional. What I want you to get from this is that there are 4 different types of ways you can merge data frames or tables together. An inner join shows IDs that are in both data frames. A left join takes a table on the left and it appends data to the right of it regardless of whether there is a match. A right join takes the table on the right and appends data from the left table regardless of whether there's a match. And a full join takes both the left and the right tables and it will just throw both tables at each other. And if there's a match, there's a match. If there isn't, there isn't. But it will show IDs in both tables. This is just summarizing that if you're going to merge 2 data frames together based on a column, you need to decide what the output you want is. You either want the inner join, which contains whatever they have in common, the left join, which shows everything on the table on the left, the right join, which shows everything on the table on the right, and a full join, which shows everything on both tables. So how you merge tables together requires you to think about what type of join you want. Do you want it to be inner? Do you want it to be left? Do you want it to be right? Or do you want it to be full? There are other names that are generally used in industry to describe these types of joins. An inner join is known as a one-to-one relationship. This makes sense because what you are doing is you're taking a table on the left and a table on the right, and you're joining them so that you're only showing matches that exist in both tables. So theoretically, every ID on the left table is matched to exactly one ID on the right table. So you have a one-to-one relationship. A left join can also be referred to as a one-to-many relationship. Basically, you're using one data set as your primary source of data on the left, and you're going to take that table and you're going to merge it to whatever exists on the right. That's the reason why it's referred to often as a one-to-many relationship. Right join is a many-to-one relationship, and a full join can be referred to as a many-to-many relationship. Another thing you should know is that for all the joins we've discussed except inner join, you can add the word outer to the join and it will perform the exact same functionality. For example, a left join is also known as a left outer join. A right join is known also as a right outer join, and a full join is also known as a full outer join. So there are many different names that people use to refer to these various kinds of joins. So now that we've discussed the theory of how joins work, let's go ahead and perform some joins. In base R, merges or joins, I will use those words interchangeably, are done using the merge function. If you want to see documentation on merge, type $merge into the RStudio console. Let's go ahead and look at that. So if I type in $merge and press enter, I'm going to look to the right, and we are working with data frames. So this is the documentation you'll be interested in that will describe to you how to merge two data frames together using the merge function. As some introductory information, X and Y are going to be the data frames that merge together, as you will soon see. The next thing we're going to focus on, beyond the two data frames we're going to merge, is this by argument. You can see that by is used to specify the columns you're going to use for merging. All is where you specify what type of join you want. Depending on how you code all, it will either be an inner join, a left join, a right join, or a full join. And you'll see this in a second. So let's start by talking about an inner join. Remember, an inner join is when you only want the IDs that are common in both tables. So let's perform an inner join between DF and cities. I'm going to go to my R Markdown file here, and I'm just going to type in here inner join between DF and cities. And remember, we're just showing IDs that are in both tables. If I go up, I'm going to add in an R code chunk. And what I'm going to do is I'm going to type in head because I don't want to print out the whole data frame. And I'm going to type in merge X equals the table I'm going to throw on the left, which is DF, Y equals cities. So this is how you do an inner join. All you do is you specify the two tables you're going to merge together. Let's scroll up and hit the knit button. And if I scroll down, I can see that city has indeed been appended to the DF data frame. By doing this, what happens here is that an inner join has been performed between DF and cities. The IDs that are in here, if I were to load up this data frame into R, would only be the IDs that are in both tables, DF and cities. Let's look at the documentation for a sec. Observe that I did not specify by and I did not specify all. By default, if you do not specify all, R assumes that you're working with an inner join. By default, takes on this value right here. It is equal to the intersection of the two names of the data frames that you provide into the merge function. What does that mean? Look at the column names of the first data frame and look at the column names of the second data frame, and whatever they have in common, use those to perform the join. And we know from looking at these two data frames up here, I'm going to click on these arrows, that the only column name that they have in common is this ID column. By default, when I put these two data frames into merge, it is joining by ID by default, because ID is the only common column name between these two data frames. If I wanted to be a little more picky, and I wanted to more specifically specify the column name I'm using, I could do something like this. If I just added by equals ID, this would give me the same result as what I just showed you. It's just that in this situation, I am being more explicit about the fact that I'm joining based on the ID columns of both data frames. You may also run into some situations where two columns actually mean the same thing, but they have different column names. In that situation, what you'll want to do is this. If I go to the documentation out here, I observe that if I wanted to, I could do a by.x or by.y. So, going over here, this isn't necessary for this situation because the column names are the same. But if I, for example, had a column that meant the same thing in both DF and cities, but they had different column names, I can use this construction instead. In this case, it's unnecessary because merge automatically assumes that you're just joining based on the ID columns in both data frames because ID is the only common column name between the two data frames. But if you ever run into a situation where the column name is not identical between the two data frames, this is what you can do. And that's actually quite common. Going back to the slides, the next thing we can do is discuss what a left join looks like in R. The only difference between the inner join and the left join in R is that in the inner join, you just specify your data frames. In the left join, you have to do the additional work of saying all.x equals true. Why does this make sense? The reason why is because if you imagine DF on the left and cities on the right, which are what R calls X and Y by default, you're saying I want everything in X to remain the same. So you're using everything in X, i.e. the data frame DF, as your source of IDs. Let's go ahead and do this in R Markdown. I'm going to copy and paste these lines, throw in a blank line, and now we're going to perform a left join between DF and cities. So we are now showing IDs that are in DF and appending cities data. And the only difference is between the inner join and the left join is you do all.x equals true. Just so that you can see this for a quick second, I'm going to call this temp, just so you can see what's in here. Delete this parenthesis. I'm going to press Control Enter. And if I go to the right, I can see temp has been created. Let's open this up and scroll through it. So you can see here that I have on the left my DF data frame, and cities are being appended to it if there is a match. If there is no match, the city is just NA. For this reason, what we've done is a left join. We're taking our DF data frame, we're just appending cities to it, regardless of whether there is a match. I encourage you to scroll through this just so that this concept gets solidified. For now, I'm just going to get rid of temp. I'll just put head around this. And now let's hit knit. And if I scroll down, these are just the first 6 rows of that left joined table that I just showed you. In this situation, we had the DF data frame with city values appended to it. In this situation, ID1 was in DF, but it wasn't in cities. So the city values are just NA. The next example is the right join. Remember, with the right join, in this situation, we would be using cities as our main source of IDs, and then appending data from DF wherever we can. If there is no match, there is no match, and then we just end up with NAs. Let's go to R Markdown. Let's copy and paste these lines of code. Throw in a blank line. We're going to do a right join between DF and cities, and this is showing IDs that are in cities and appending DF data. And the only thing we need to change from the left join is now, instead of all X equals true, all Y equals true. Let's just temporarily call this temp, just so we can look at it. I'm going to get rid of the parenthesis over here and press Control Enter. Let's go to the top right and open up the temp variable. So notice over here that we're not staring at an ID of 1 like we did in the last data frame. Instead 2, and then we skip all the way to 13. These ID values, if you were to dig into them, would be in cities, but not in DF. However, wherever we do find a match, we append data from DF to these specific IDs that we got from cities. For this reason, we have a right join between DF and cities. And if you were to dig into this more, you would find that there are particular IDs that have a city value because their IDs are coming from the city's data frame, but aren't in the DF data frame. So remember that with the right join, you're just taking the IDs from the right data frame and you're appending stuff from the left data frame, regardless of whether there is a match or not. The last type of join we need to discuss is the full or full outer join. How you do that in R Markdown is as follows. I'm going to copy and paste these lines of code. And I'm going to change these temps to use the head function. And this is a full join between DF and cities, which just shows IDs that are in both DF and cities, and matching where applicable. Oh, and another thing I need to change about this too is I need to add all.x equals true. So remember, with full joins, you have to show records that are in both tables, regardless of whether or not there's a match. I'm going to hit the knit button. If I scroll down, this is the start of the output of that full join, which contains IDs that are in both tables, regardless of whether there is a match. And that's really it for my lecture on joins. I realize that this is a lot of information thrown at you when it comes to how R works with data manipulation. So I strongly recommend that you look through this summary slide and you make sure you understand how to answer these questions. Everything we're going to do for the rest of the semester is going to build on top of these foundational concepts. What we're going to do after this is we're going to do the exact same things we did in base R, except then in dplyr, then SQL, then Excel, then Access, and then Python. So make sure you know how to answer these questions so you don't get lost in future lectures. The last thing I want to let you know about is that a lot of old or misinformed code will use the subset function in R for filtering. For reasons I will not get into, please do not use the subset function in your code. You might be wondering why I'm telling you this, and here's why. If I go to the console and I type in $subset, and if I look on the right, it says right here that the subset function is a convenient function intended for use interactively. For programming, it is better to use the standard subsetting functions like the brackets that I've introduced you to. If you go on websites like Stack Overflow, you're going to see answers, often recorded as the best answers, that use the subset function for filtering. Please do not use the subset function in R to perform filtering. Please stick to brackets with Boolean indexing and using which, if you would like, to filter your data as well as filtering your vectors. So let's go ahead, since we're done, and commit the RMD and the HTML to your Git repository. Go to your DSci 2000 folder, click Git bash here. Let's do a commit. And let's do a Git push. Let's close out of Git bash. Let's open up RStudio and close out of RStudio. Remember not to save your workspace. And that's it.